Math 7, Unit 7, Lesson 5, Experimental Probability. In the last lesson, we created a probability model using the bag of blocks worksheet. We're just looking into things a little bit more deeply here. First, let's look at some experimental probability here. Determine the theoretical probability of a couple having a baby boy. Well, theoretically, only two options. One out of the two would be boy. Now, actual data does suggest that it's not 1/2. It's, depending on the country, somewhere between 50 and 55%. Number 2, determine the experimental probability of having a boy for parents of the 7th grade class at the time they were born if there were 100 girls and 140 boys. All right, this is experimental probability, so it is based on the data. 100 girls, 140 boys. That's 140 boys compared to 240 students total. And if I just take a quick 140 divided by 240, I get 58%. 58.3%. So this was a class of 7th graders that were at the school several years back, and there were 58.3% boys. All right, gonna roll a die 50 times and record the results below. So we'd go through and we do this 50 times, but that would take quite a bit of time. So I have previously done it for the purpose of this video. When doing it 50 times, I got 10 1s, 7 2s, 8 3s, 11 4s, 4 5s, and 10 6s. Okay, if I take just creating a bar graph of this, a histogram, if I've got 10 1s, I just make a bar that's 10 tall. I've got 7, that's between 6 and 8. We'll get into statistics in Unit 8, and we'll be doing a lot of these histograms. Okay, 4 is 11, 5 is 4, and 6 is 10. Okay, so nice graph. Let's look at some of the probabilities we have listed down here. Actually, I need some sort of tool here. Here we go. Okay. What's the experimental probability of rolling a 5? Well, 5 happened 4 times out of 50, giving us a probability 2 out of 25, or 8%. So we didn't get very many 5s compared to theoretically. Theoretically, it's 1 out of 6. There's 1 5 out of 6 total outcomes, and that means 16.7% is theoretical probability. So according to our data, we did not roll very many 5s at all. Okay, what about rolling an odd number? Okay, odd numbers would include 1, which there was 10, 3, there were 8, and 5, there were 4, giving us a total of 22 out of 50. 22 out of 50, that would be 44%. Of course, that reduces nicely to 11/25. Okay, theoretically, there are 6 outcomes. 3 of them are odd numbers. Theoretically, we should get odd numbers 50% of the time. And here we ended up getting it 44% of the time, which is a little less than we would expect, but it is what happened. Okay, not rolling a 5. 2 ways I can do not rolling a 5. Realizing that not rolling a 5 and rolling a 5 are complementary events, I can just take 100%, subtract the probability of rolling a 5. Or I could add up the times that we got a 1, 2, 3, 4, or 6, and then put that over 50. Either way, you either get 46 out of 50, or you would just get 92% if you did the complementary probability. Now, not rolling a 5 theoretically, 5 out of 6, you get 83.3%. So, not rolling a 5 happened more often than would be expected. Okay, not rolling a 4 or 6. 4 happened 11 times, 6 happened 10 times. So, 4 and 6 happened a total of 21 times, which means it did not happen 29 times. So 29 out of 50, that doesn't reduce nicely, but it is 58%. Let me double check that. That was just calculated in my head. It is 58%. Not rolling a 4 or a 6 should be 4 out of 6, which is 66.7%. So, we actually rolled more 4s and 6s than would be expected. Okay, next, rolling a 7. I go up here and look at my data. I rolled a 7 a grand total of 0 times. It never happened. There is no 7 on the number cube. So, experimentally it was 0%. Theoretically, also 0%. There's a really important idea right here. If a probability is, well, if the likelihood is impossible, if an event is impossible, the theoretical and experimental probability will both be 0%. If you ever get experimental data for something with 0% probability, that means your theoretical probabilities were incorrect. Now, there is no 7 on the number cube, so that's why it's 0%. Okay, rolling a number. I rolled a number 50 times out of 50, which is 100%. Now, theoretically, it's 6 out of 6, which is also 100%, which this is an example of a certain event. When an event is certain, the experimental probability and the theoretical probability will be identical. Okay, all right, we're rolling a die 50 times. I did save some time on this and did it previously, so you can see the data already listed here. So this is out of 50 times. Okay, let's look at experimental probability. We'll go through and calculate all of those first. I rolled a 1 0 times, that's 0 out of 50. That's 0%. I rolled a 2 1 out of 50 times, that's 2%. I rolled a 3 3 out of 50 times, that is 6%. 4, I rolled a 4 2 out of 50, which is 4%. A 5 was rolled 4 out of 50, which is 8%. A 6 was rolled 11 out of 50, which is 22%. A 7 was rolled 7 out of 50, which is 14%. An 8 is rolled 10 out of 50, which is 20%. A 9, 5 out of 50, which is 10%. A 10, 6 out of 50, 12%. An 11 is 0 out of 50, 0%. Now, does that mean rolling an 11 is impossible? It doesn't. It just means it never happened in the 50 trials that I rolled the die. 12, 1 out of 50, which is 2%. Okay, which number occurred most often? We got 6. That's what is expected. Now, if you know anything about rolling 2 dice at the same time, what is expected to happen the most often is 7. 7 can happen several ways. You can get a 1 and a 6, a 2 and a 5, a 3 and a 4, or with those backwards, a 4 and a 3, a 5 and a 2, and a 6 and a 1. So there's several ways you can get 7. Now 6 is really close to 7, so is it expected that 6 could happen the most? Yeah, that's reasonable. That can reasonably happen. Now, what number occurred least often? 1 and 11. What's expected? Well, if you think about the number 1, 1 is impossible. So we should expect it to have not happened. 11 should have happened more often than 12 or 2, but it's not really that far out of expectation for it to have happened. Now we can actually do the theoretical probability for these. Let's take a quick look here. What we would want to do to figure out these theoretical probabilities is look at the array of possible outcomes when you roll 2 dice. Now, so that you can understand here, they've been colored. The first die roll would be red and the second one blue. The first die roll can come out 1, 2, 3, 4, 5, or 6. And the second die roll can come out 1, 2, 3, 4, 5, or 6. And let's say you rolled a 2 and a 3. Here's that outcome. You rolled a 5 and a 5. There's that outcome. So all outcomes are represented here. And this is a 6 by 6 grid. So there are a total number of outcomes here of 36. Okay. As far as the numbers, you can see that 1 does not happen. 2 will happen once. 3 has 2 ways of happening. 4 has 3 ways of happening. And you should see a pattern occurring here. So 5 should have 4, 6 should have 5, 7 should have 6, 8 should have 7. But actually it doesn't. Let's look back at this. Because once we get up to 7, things start going back down. So here's 7. 7 has 6 options. Now, as I move to 8, 8 only has 5 options. It starts dropping back down in size. So 8, the probability of rolling an 8 goes down to 5 options, 5 favorable outcomes. 9 has 4, 10 has 3, 11 has 2, and 12 has 1. So these are all out of 36. So we go back here. Figuring out the theoretical probability. This is 1 out of 36, which is 2.7 repeating percent. Then we've got 2 options out of 36 for the 2, which is 5.5%, 5.5 repeating. 3 out of 36 should be 8.3%. 3 out of 36, 8.3 repeating percent. 4 out of 36 should be, oops, I typed in the wrong number. It's 11.1%. That's 4 out of 36. 5 out of 36 comes out to be 13.8%. 6 out of 36. Oh, I've made a mistake here. All of these I am off by 1. Let me just move them all down. Because 1 has a probability of 0 happening. Okay, I've got these lined up correctly. 7 can happen 6 out of 36 ways, which is 16.7%. And then these start dropping down. 5 out of 36 is 13.8 repeating percent. I guess that's 0.6 repeating up there. 9 can happen 4 out of 36 ways. That's 11.1%. 3 out of 36 ways for a 10. 8.3 repeating percent. 11 can happen 2 out of 36 ways, which is 5.5 repeating percent. And 1 out of 36 ways you can get 12, which is 2.7%. Now, if we make a comparison here, theoretical probabilities should be pretty close experimental probabilities should be pretty close to theoretical, especially for a high number of trials. Now, there are 36 different outcomes, so 50 trials is not very many compared to the outcomes being 36 possible. If we did this several hundred times, maybe even a few thousand times, the numbers would come out to be very close. The issue here is 36 outcomes and only doing 50 trials. We're not going to get as much accurate data. It's going to be close. I mean, we take a look here. We got a 9 10% of the time, and it's expected to be 11.1. That's pretty close. A couple of them were a little far off. 11 happens 0%, we'd expect 5.5. I mean, that's within 6% of what we would expect. The most common one was a 7 at 16.6 repeating percent, and we had 14%. Those are actually pretty close. So all of this was reasonable. Let's get into the notes on this. So this is on page 101 of your notebook. Vocabulary, theoretical probability. The probability calculated by looking at possible outcomes. For example, the probability of getting heads on a fair coin is 1/2. Experimental probability. The probability calculated based on actual outcomes of many trials of an experiment. So based on 9 coin flips, where you get heads, heads, tails, heads, tails, 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 heads, tails, the probability of heads would be 4 out of 9, because 4 out of 9 times, the outcome was heads. Frequency is the number of times something happens. For example, the frequency of heads in the example above is 4, because heads happened 4 times. Relative frequency, the ratio of an outcome to the total number of trials in a data set, another name for experimental probability. The relative frequency of heads in the above example is 4/9, or 44.4%. It is helpful to compare theoretical and experimental probabilities side by side. Realize that experimental probability, or relative frequency, is the number of times an event occurred divided by the number of trials. Theoretical probability is all based on outcomes, the number of favorable outcomes compared to the number of total outcomes. Of course, we assume that every outcome is equally likely. Experimental probabilities tend to approach the theoretical probabilities for large numbers of trials. This is referred to as the law of large numbers, which we will come to understand. Now, on your bag of blocks, if that experiment were conducted more than just 25 times per bag, let's say it was conducted 2,000 times per bag, the data would come out to be more closely representative of the theoretical probability, the actual number of blocks in the bag of each color compared to each other, which is what you would need to know for the theoretical probability on the bag of blocks worksheet. You'd have to actually inspect what's in the bag. Okay, examples. A number cube was rolled 500 times. The results were recorded and summarized in the bar graph at the right. Determine the experimental probability, or relative frequency, of each event. Give answer as a percent. So rolling a 3. All right, for experimental probability, you need to look at the number of times it actually happened. A 3 was actually rolled 75 times. Now we need to divide that by the number of trials. There were 500 trials. So 75 out of 500 trials, it came up 3, which is 15%. Rolling a number greater than 4. All right, numbers greater than 4 include 5 and 6. 5 happened 72 times, and 6 happened 82 times. So 72 plus 82, that's 154 times out of the 500 trials. And that gives us a probability of 30.8%. Also relative frequency. It happened 30.8% of the time. Okay, rolling a 3 or a 5. Now 3 or 5 happened 75 or 72 times. 72 plus 75 is a total of 147 times out of the 500 times. This gives us a probability of 29.4%. Experimental probability, or relative frequency. Next, a number cube is rolled. Determine the theoretical probability of each event. Now you should notice that these are the exact same events as the ones above. The difference here is theoretical probability. You need to fully understand the difference between theoretical and experimental probability. Experimental probability is based on data. Theoretical is based on outcomes. So, rolling a 3. There are 6 outcomes on a number cube, one of which is 3. This gives you a probability of 16.6 repeating percent. rolling a number greater than 4. Well, there are two outcomes, 5 and 6, that are greater than 4. Two outcomes out of the 6, that is 33.3 repeating percent. Rolling a 3 or 5. This is the same as what we just did. Two numbers are 3 or 5 out of the 6, that's 33.3 repeating percent. Now, as we make comparisons here, on the very first one, a 3 happened slightly less often than we would expect. A number greater than 4 happened less often than we would expect. And rolling a 3 or 5 also happened less often than we would expect. And if you look at the bar graph, it looks like rolling a 1 happened the most frequently. And that happens with random events. That's just chaos. Okay, a little bit of hints into your assignment on this. Theoretical experimental probabilities. On number 1, you're doing the spinner, and it's got the bar graph there with your data. It uses the term relative frequency. Remember, that's the same thing as experimental probability. So make sure on A, B, and C you're doing experimental probability. Now, be careful with the way D is worded. Read it carefully. If you spin the spinner once more, what's the probability you will get a 1? This, if it's something that has not happened yet, this is going to be theoretical. So just based on that, what would it theoretically be? Number 2, we've got experimental probabilities. We're going to just calculate them based on some data. 3, you'd add or subtract, multiply, and divide fractions. Number 4, review of finding volume. It's multiple choice. Number 5, you are given a probability, theoretical probability. Now, theoretical probabilities are based on outcomes. So you can use theoretical probability to calculate how many pop songs there are, because theoretical probability is all about the outcomes. Number 6, review of finding the perimeter and area of this shape. Number 7, we've got 2 coins being flipped 12 times and answering some questions on it. Well, actually, that was 1 coin. The second, starting at C, is 2 coins being flipped 100 times, and you answer a couple questions about it. Keep in mind the difference between theoretical and experimental probability. Experimental probabilities are based on collected data. And then number 8, you conduct an experiment where you pick 7 tiles out of a bag. Use this experimental data to estimate the number of vowels in a 100-tile game. All right, please complete probability.4. You can print it off, or if you got it from the packet, that works too. And thank you for watching.